Hello. Today we're going to look at file input and output in C++, and basically how do you write to a file, how do you read a file, how do you add to a file, and setting permissions so that you're allowed to do so. So in our first exercise, we're going to write a program that opens a file named lecture6b.txt, then prompt the user to enter 5 numbers and write them into the file. So we are now not going to be using notebooks for this. We'll be using normal CPP files. So here is what we have to do, and I will call this exercise1.cpp. Okay. So we need to open a file. So we want to include IO streams so we can prompt the user and get input from them. We also want to include F streams so that we can actually, handle files. And we need a main function where we can actually do this. Okay, so in order to open a file, just peeking back at the syntax, we need fstream, which we have, and we need to open an OF stream, that's short for output file stream. And so I'm actually just going to yoink this code here because this mostly is the things that I want to start with, but we're obviously going to change the things to do what we need. So we do want to open a file. The file is, however, not going to be called newfile.txt. It's going to be called lecture6b. And we're not going to write a single thing. We're going to write multiple things here. And then we'll close it when we're done. And now, to enter 5 numbers, we'll need a loop that's going to run 5 times. And we're going to prompt the user to write something. So please enter a number. We need to store their number in a variable. Just read in their number. And then we're going to write that to the file. And so to do that, we do it sort of the same way that you would with cout. Just instead of cout, we have my output. And we'll send in the number and a new line. Okay, let's try this out. So, terminal, ++, example 1. Okay, we got some errors. Let's see what I messed up. OF stream was not declared. Yes, I did mean std : OF stream, but since I forgot to write using namespace std, the whole thing is very mad. So let's make sure that I have that as well. We'll clear our terminal and try again. All right, seems happy. And if I run it, enter 1, 2, 3, 4, 5. Looks like that worked okay. And lecture6b has my numbers 1, 2, 3, 4, and 5. Hooray! Written my first file using C++. Great. Now we can move on. Okay, next exercise. File reading. Modify your previous program so that it prints out the contents of the file you just created. So we will make a duplicate of this example. We will call this example 2. And we want to keep all of the stuff that we had from before, but we also want to open the file for reading. So after I've closed it for writing, then I can open it for reading. And the only difference here is that instead of using output, we're using input. So it's my input as an IF stream instead of my output as an OF stream. I, of course, also want to close it when I'm done. And now I want to read through all the numbers that are in it. And so there's a number of different ways that I can do this. You can use getLine. I think what I'm going to do is I'm going to store these in a variable and then print that variable. So we'll make another number, and we'll do while my input read into the number. This is a little bit of a hack, I guess is one way you could call it. And so what's happening here is that I've actually inserted a statement into my condition. A little unorthodox, but it's a little bit convenient for understanding what's going on here, which is that I'm going to take from my file, read into the number variable, and every time I do, there is technically a return value for this statement. There's something that it evaluates to, and that happens to be true if it worked. If there is nothing left to read, it will be false. And what basically now it means I've done is I've created a while loop that will keep reading in while there are things to read. And as long as there's something to read, I want to output the numbers are. And read out all the numbers. Okay, let's try this out and see what happens. Seems to be happy. So let's say my numbers are 10, 12, 14, 16, 18. Looks like it did not read them back out to me, so that's no good, and that's because I compiled the wrong file. Let's try it again. Compile this one. There we go. Try a second time. 10, 12, 14, 16, 18. And the numbers are 10, 12, 14, 16, 18, and I can close this and reopen to see that my text file now has the new numbers, and it read them all back to me very nicely. There are more ways to read in besides just doing this. But this is very convenient for the program we're working on because we know each line just has a single number we want to read in and nothing else. We can store that into our integer variable, and we can even use that if we want to. But that's it for this one. On to the next. Okay, so next exercise. We're going to append. We're going to modify our program to append instead of writing, meaning instead of overwriting what's there, you'll notice I got when I put in new numbers, it deleted the old ones. I want to add to it. And then I also need to still make sure that all the numbers in the file are printed. Now, if you had just made a loop that ran 5 times, then you would only print out 5 numbers every time, but that's not really useful. Instead, we're going to use the fact that getLine and also the line that I wrote returns false if there's no more lines to be read. So I've actually kind of done the second part already, but in case you just wrote a loop that ran 5 times, now you would need to be able to use this to make sure that you print everything out. But turns out the modification is actually trivial. And I really mean it when I say trivial, in that as long as you know what to write, it's almost instantaneous, which is simply, when I open it for reading, I need to add that I want to input-output stream append. And that's it. Simple change. But now when I run it, let's compile exercise 3. And now remember that right now we have 10, 12, 14, 16, 18. So let's add some new numbers into it. Say 30, 40, 50, 60, 70. But now you can see every single number has been added. I didn't overwrite the ones that were there. And in fact, now my file has all of the numbers. And I can even run it again, put in 2, 3, 4, 5. And now it adds in all of those as well. If you notice, it doesn't reflect here because I have not refreshed it. So you do need to close this, reopen it to actually see the change has happened. But it's as simple as adding in a very small parameter to opening the file in order to get it to append instead of to write. Okay, on to the last one. Okay, last exercise uses writing permissions to see what happens when I try doing this with different permissions. So we're going to run our program to make a new file with 5 numbers. So we'll delete the old one, make a new one, and then we'll try changing the permissions to see what happens when we have some permissions allowed and some not allowed. So here we're not really going to need to code much more because our coding is basically done. And if I want to see what the permissions are, I can actually type ls space -l. And what this will show me is for each file what permissions are available for the user, the group, and the other. I think the first dash is not any of those actually. So if I look at, for instance, lecture 6b, right now everyone is allowed to read, and I am the owner, am allowed to write to it. But first of all, let's delete this because it has too many numbers in it. We'll run our program. Let's just add 1, 2, 3, 4, 5. So those are our numbers. We can do cat lecture 6b, and it will tell us what the numbers are in it, just to confirm that those are there. And again, if I look at the permissions, okay, I'm allowed right now to read and write to lecture B. So the first thing that it says is remove reading permission. So let's see what happens if I make it so that I am no longer allowed to read lecture 6b. And there's a number of different ways to do that. One of them is chmod user minus read from lecture B. And so now you can see I no longer have read permission to access this file. And so what happens if I run it again? Let's say I do 6, 7, 8, 9, 10. Notice I'm not able to print out the numbers because when my program tried to read from it, the computer said, no, 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 you can't do that. Was I able to write to it is a question. And it turns out if I try to open it, there's a file load error because I've been denied permission to read it. So let's see what happens if I restore my reading permission. So I can do chmod user plus reading from lecture 6. And now what is in it? And look at that, I was able to write, even though I wasn't able to read. I was allowed to add these new values to it, but I couldn't open it because I did not have read permission. So that was what happens when we removed reading permission. What happens if I remove writing permission? You can probably guess what will happen, but let's confirm it. So let's remove writing from that file and run it again. And let's say I do 20, 30, 40, 50, 60. You'll notice that none of those got added to our file. I can still open it, but none of this can be changed. If I decide to go write 100 in here, and I try to save it, permission is denied. I simply am not allowed to do so because I've removed the writing permission. So in order to fix that, I once again have to add it back in. But what happens if I remove both? So chmod minus read from lecture 6b, and I run my program, 1, 2, 3, 4, 5. Now no longer will it print anything out, and if I restore those permissions, chmod u plus reading and writing, that last execution of the program did nothing. So it's a brief demonstration of how chmod works. I encourage you as extra practice to try doing this without using u plus and u minus. If you use the binary codes, there is another way that you can do it. So see if you can figure that out. It's a good practice for your test. So thanks for watching, and I'll see you in the next clip.